something with an exponent, a little bit more detailed there, is when the variable it all comes back to grade 9 and 10 when we looked at exponent laws. What? Stuff from grade 9 and 10 is important now? Crazy. Here's just a few of the ones, the most important ones we're going to use. The other ones are on the sheet that you got on Monday. Two bases, we're multiplying. What do we do with the exponents? Add them. So this is x to the m plus n. One base, two exponents? Multiply. N times n. To some brains, these look very similar. So let's just talk, what's the difference between these? A square to a square.
It's like saying what's 2 plus 2, or what's 3 or 3 times 3.
With the exponents, yes, but what's difference in the question? How many bases? 2. So same one, but you see it twice. How many bases here? 1. So this has 2 bases, this has 1 base. 2 bases, 1 bases. And just because I have a feeling no one ever showed you why these laws are what they are in grade 9, let's just talk about why this is. So let's do x to the 2 times x to the 3, for example. So we know from the law that's going to be x to the 5. Let's talk about why. Well, what does x squared mean? X times x. And what does x cubed mean? And what does x to the 5 mean? Do you see why those are the same? Okay. Let's take the same thing but turn it into the other kind of question. So what does anything cubed mean? So imagine that's just an x. So this means x squared times x squared times x squared. What does x squared mean? And the second x squared? And the third x squared? And we know from the exponent law this is x to the 6, which is? Whew, whew, whew. Do you see now why those are equal? So I think nobody showed you that in grade 9. It makes a little more sense when you write it out. That's why we're adding here, why we're multiplying. Division. Well, why? Did you just sigh? There will be no sighing in math class. He did. He had a hard lunch hour. What does the top mean? What does the bottom mean? And we can cancel one on the top with one on the bottom, and another one on the top and another one on the bottom. And what do we have on the top? That's why we're subtracting, because you cancel on the bottom. Whew. This one was not in your sheet. This was a grade 10. No, it was on your sheet. It was on the sheet. We added this one in grade 10. Negative exponent freaked you all out in grade 10. What does it equal? 1 divided by x to the n. So if you have a negative exponent, it turns positive when you put it under 1. We added this one too in grade 10. Freaked out, you didn't like it. We looked at a whole unit of radicals, and then we graphed them this year. We solved them. Well, radicals are actually just exponents. So we taught you in grade 10 how to turn a square root into an exponent. Square root equals a half. So roots are just fractional exponents. And if we had something different than a squared, so it was a cube root, a fourth root, a fifth root, this becomes x to the 1 over n. Well, who taught you in grade 10? I thought it was me.
Oh, it was you.
It was me. Pretty sure it was me. Paper. Sorry, what?
The alternate was more fun.
No, the hitting was more fun.
Of course, yeah, but you didn't get clean to the wall.
Once you have the example copied down, just put your pens down. I just want you to watch me, so don't try to copy and do, just watch. And then we'll talk about a method, then I'll come back and redo it with you. Okay, what's the purpose of any equation? What are we trying to find here? X. We got to figure out what's the number that when I put in for x makes the two sides equal. Just like any equation, we're solving x. The trick with exponential equations is I'm just going to use some substitution. I'm going to take 4 out, and mathematically I can do that as long as I replace it with something that's equal to 4. So there are lots of things that are equal to 4. I can make it 6 minus 2. I can make it 2 times 2. I can make it 8 minus 4. I can make it 100 minus. I could make it 8 times a half. I could put in anything I wanted to mathematically as long as the two are the same. I'm going to choose to replace it with 2 squared. Okay, so do we agree I haven't changed the equation, I've just changed what it looks like. Haven't changed the value. Well, this is an exponent law, and it says if I have one base, what do I do with those exponents? I multiply them. So I'm just going to simplify using that exponent law, and 2 times 2x, if I multiply them, gives me 4x. Still with me? Okay. Ooh. Thank you. Couldn't read my own writing. Now we're good? Well, then there's a little law in math that says if you have 2 bases and exponents that are equal, if the bases are equal, the exponents have to be equal. If the bases are equal, the exponent has to be equal. What that means is we can't have 2 to the 7 equal to 2 to the 5. Think about that. Can 2 to the 7 be equal to 2 to the 5? No, 2 to the 7 can only be equal to 2 to the 7. It's the only thing that makes sense. So using that law, what I can do is actually just drop these bases and equate the exponents. That's now a grade 7 linear equation. How do we solve for x? Okay, do you want to move x's to the left or x's to the right? Okay. There's an exponential equation. We're going to do a method first, then we're going to copy. Jen is already trying to copy there. Okay, so we're going to play that game where you give me the method and it's really bad, and then we work together to make it better. Yeah, remember that game? Okay, what did I do first? Yes, I wrote down the question. So I want to change every base to be a, we call it a common base. Change every base. All about that base. To a common base. Oh, God, I put it in Noah's head now. All class. Change, that should have been all bases to a common base. Usually that's the smallest number, but it doesn't always have to be. But typically you can't change a big number, or small number into a big number, so typically bases are getting smaller. So 4 went to a base of 2. Okay, so that was this step. How did I get to this step here? So where did this 4x come from? So I simplified using exponent laws. You guys are getting better at this game. This is the most fun step. Drop the base. We call that equate the exponents. Equate the exponents. And solve. Now you may copy. And I'm just going to do it again with you. What was the sigh for? Why do you keep sighing?
Me?
Yes.
Oh, no, that was that. You dropped the base.
Oh, very good. Step number 1, 4 is going to come out, and what are we going to put in its place? 2 squared. Why did I pick 2 squared? Because there's a 2 on the other side. Step 2, we're going to simplify using our exponent laws. 1 base, 2 exponents, says we multiply. So 2 times 2x. Step number 3, there's a law that says if the bases are the same, the exponents are the same. So we get to equate the exponents and solve. Okay, minus x from each side gives us 3 equals 3x.
This could be our new song.
It could.
We could begin more music.
X equals 1. Now you can check any equation, and these are good ones to check on the exam because they're really easy to check. It's not like some of the other sinusoidal ones that we've done. How do you check any equation once you've solved it?
Plug it back in.
Yeah, go back to the original, let's put in our answer and see if it works.
Do we have to?
You don't have to, but again, these are easy to check. So if you're on the exam like, oh my God, I don't know if I got this right, check it. Okay, so here we have to add first, so this gives us 2 to the, and 2 times 2 times 2 times 2 equals,
16.
okay, so 2 times 2, 4 times 2, 8 times 2, 16. And on the right, we have to multiply first, 2 times 1, and 4 squared is. If you made a mistake. Okay, let's look at number 2. Common base, common base, common base. So we look at 4 and we look at 8. And can I change 8 into a base of 4? Ooh, 4 squared is 16. You're just a step ahead of me. Can I change 8 into 4? No, but what can I do with both 4 and 8? So the 4 is going to become 2 squared. And I like to bracket when I substitute. And 8's going to become? Okay, so sometimes you have to change both to get a common base. That's okay. Step number 2 is what? Simplify using exponent laws. If I have 1 base and 2 exponents, 1 base, 2 exponents, multiply, so 2 times x, 2x. Be careful on this side. For visual people, it might help if you bracket that binomial, because in a second when we multiply, that 3 has to apply to everything. So sometimes if your brain doesn't see the brackets, it'll just do 3 times x, but we'll miss the negative 1 times 3. Okay, so 3 times x and 3 times negative 1. Again, so for some brains, you need those brackets just to see you're distributing. How do you know when we're done simplifying? Bases equal, and more specific, how many bases are we down to on each side? 1 on each side. So I'm going to repeat that. You're done simplifying when A, there's no brackets, like always, but B, there's only 1 base on each side. 1 base on each side, done simplifying. Step 3, the fun step. Whoosh. X is to the left or x is to the right? Okay, so if we minus 3x, let's check it just for fun. Okay, 4 cubed, so 4 times 4, 16 times 4. Other side we have to subtract first, so 3 minus 1, 2, 8 squared. See, do you see how they're really easy to check? So again, it takes 2 seconds. If it's one like this, check it on the exam just to make sure you have the right answer. Let's look at freaky number 3. Ooh, radicals. You mean once we learn something in math, it doesn't go away? Keeps coming back forever? Common base. Yes, so what do you want to do with this for?
Get rid of it.
Now I'm going to deal with this radical. We have an exponent law that we just talked about that can change it to an exponent. So I'm keeping the left. I'm keeping that 2 squared, not touching it yet. All I'm going to do is just take that root and change it to the exponent of 1/2. Are we done simplifying? How do we know when we're done? 1 base on each side. I got 1 base on the left. That's okay, but ooh, over here. This is the other exponent law that says if we have 2 bases, what are we doing with the exponents? Okay, and let's just combine that off to the side. Fractions don't scare us after identities. Oh, somebody already got this 5 on 2. Let's talk about why it's 5 on 2. So under the 2 is? And then we need a common base of 2, which makes the first numerator. And then we add it with the, which gives us? Now, are we done simplifying? How do we know? 1 base. Then we get to?
Drop the base.
Last year on the exam panic, you all go through it. Someone called me over like, oh my God, okay, yes. I don't know what to do here, I'm stuck. And I'm like, what do you mean you're stuck? I don't know how to solve for x. What do you mean you don't know how to solve for x? So if you get down to this part and you have x equals a number, guess what? It's done, it's done. You don't need to solve, it's there, it's good. What's the answer? 5/2. Okay, so no exam panic, it's all good. 4 is as hard as they're going to get. Basis first. Basis first, basis first. 3 and 9. Which one's going to go? What would you like the 9 to become? What do we do after common base? So what did we do in the last example? Yeah, we dealt with the radicals. So this time we have 2. No freak out, no panic. We got exponent laws to cover this. Square root becomes an exponent of. And I'm leaving that x minus 1 for now. I'll touch it in the next step. And I'm going to leave the 3 squared for now. I'll touch that in the next step. I just want to deal with that cube root. Cube root becomes an exponent of. On the left, 1 base means we multiply. And again, if your brain needs the brackets to remember we're multiplying all the way through that binomial, then write them. So this is going to become 3 to the confirm. And the other one is the same exponent law. If we have 1 base and 2 exponents, we are. Now, a really common mistake here is people will say that this is 2/6. What's the mistake I did there?
It's 2/1, not 2.
Yeah, so people will want to multiply the top and the bottom. So if your brain needs to put that imaginary 1 on the bottom, then put it. And remember, it's top times top, bottom times bottom. So the correct multiplication would be 2/3. Are we done simplifying? Okay, so I heard no and yes. How do we know when we're done? One base on each side. Do we have a one base on the left? One base on the right? What do we get to do? Do you like fractions or not like fractions? Okay, so if you want to work with the fractions, go ahead. If you don't, you've got an option here. What can we multiply everything by to get rid of the 2 and the 3? So what's the lowest number that divides by 2 and divides by 3? So I'm going to choose to multiply both sides by 6. Again, you don't have to. If you want to work with the fractions, work with the fractions. So 6 times a half is 3x. 6 times negative a half. 2/3 times 6. So do top times top. 12, and on the bottom, 3. And what's 12 divided by 3? 4. 3x equals? This is not the hard step. 7. X equals? 7/3. You'll notice we get a lot of fractional answers when we're dealing with the roots. That's common. So if you get a fraction, don't necessarily think it's wrong and redo the question 5 times. Fractions are our friends.